Everyone hear me? I hear myself. That must be good enough. All right. Well, welcome back. I hope you all had a good lunch, had a good morning at Build. My name is Steve Wright. I'm a senior program manager with Microsoft. I've been with Microsoft now for about 18 years, and before that, had a number of years in the workstation graphics field with Hewlett-Packard and companies like that. Roughly the first half of my time with Microsoft was spent on the graphics side. I did a lot of work in workstation graphics, GDI, GDI+, DirectX, and then I spent the second half more on the input and window management side. A lot of NT user, Cicero, still some GDI and GDI+. In Windows 8, I spent a lot of time on touch input specifically for the web and for WWA applications or store apps. I worked mostly on the unification of the pointer input, the mouse, pen, and touch for those products. And then for 8.1, they tapped me to spend some time looking at high DPI and trying to improve our desktop DPI story, which was a good fit in some ways. I was there on the ground when we started doing high DPI support back in the Windows XP and Vista timeframe. And there's quite a combination of both input and output technology that's involved here. So I'm going to be talking about high DPI, and specifically on desktop apps. There is a lot of good content around store apps and DPI support. There's a whole talk on that. I'll give you a reference to that towards the end of this session. But for me, I'm going to be focusing on the high DPI side for the desktop. So I think the thing I want to impress on everybody here is that there is an unprecedented opportunity for you guys as developers to create visually stunning desktop applications. And I encourage you to play with the high DPI devices at your disposal. I understand you're all getting Surface Pros, have nice 200 plus DPI displays that run at 150%. And I think if you play with those for a while, you'll get some idea. But I'll try to talk through some of the reasons why this is really important for desktop apps here as well. So it's a great opportunity for you. It's a great opportunity for us in Windows. So by way of an agenda here, I want to walk through a few things. One is the thing I just basically alluded to. These high DPI machines are here, and this is really kind of a game-changing evolution for the PC field. Because it's such an important thing for us, we've done a lot of work in Windows 8.1 for desktop applications, and I want to talk about what we've done. But we also want your applications to really shine on the desktop, to start taking advantage of this high DPI. And so there's a great opportunity here for you, and I want to talk about what that looks like and what kind of investments you have to make and the options that are available to you. And then I'll take a deep technical dive, and I'll run through a lot of code samples involving Win32, Direct2D, and WPF, just as frameworks for doing some app development in, and showing how you can make those applications DPI aware and even in high DPI aware in ways that previously were not possible in Windows. So let me just spend a couple minutes on what we mean by high DPI machines are here. In some sense, Windows has supported high DPI certainly since Windows Vista, and arguably there's material we've written goes all the way back to XP that talks about how to write Win32 applications that are high DPI aware. But for the most part, the Windows PCs we've seen have been very close to 100% scaling. I think if you look at the telemetry data, about 91%, 92% of our machines are running at 100%, basically 96 to 110 DPI. And then about almost all of the remainder have been running at 125%, which would be up around 120 DPI, with just a small fraction of a percent past that point. This is changing very quickly. For starters, those are the Surface Pros we handed out, and those are just part of a whole wave of ecosystem machines that we see coming. Basically 1080p machines, 1920 by 1080 on a small enough device that they easily support 150% up to, and even past that in some ways. So those devices are available now. They're in your hands. People are buying them. There's a second wave coming. In fact, it's already pretty much started to crest. It's a good example of this is the Kira book, which is what I'm actually using to present. It's a 2560 by 1440 laptop screen, about 225 DPI, and I'm running it here at 200% scaling. There are many other devices in this class coming out as well. Then there's this 32 by 100 by 1800 screen. I think it was shown at the keynote, and James Clark was showing it in here in his earlier session today. Also scaling at 200% with the DPI well over 200. And the end is not in sight, because we've had information from some OEMs that they are looking into even bigger, denser screens, 3840 by 2160, these so-called quad HD. And those could be available with a physical density of over 300 DPI, and will certainly scale at 200%. So these are arguably premier machines. You're going to pay a lot of money for these, but every OEM we've talked to is interested in this space and is pursuing something. So they will be available widely, and it's just a question of the prices coming down for them to become more and more available. Now, as we were looking forward at this, we were thinking, what do we need to do in Windows 8.1 to provide a good story here? Well, for starters, in the past, we've only supported really out of the box 100, 125, and 150%. We provided you with a custom option. You could go in and enter your own value. And if you had one of these 200 plus DPI machines, you could use that to set it to 200%. But we didn't recognize it out of the box and give it an appropriate scaling factor, so it required work on your side. Clearly, to support this new wave of machines, we need to be able to recognize them and give them a 200% right out of the box if that's what they call for. So that's the first thing we've done. The second thing we've done, and I know this has been talked about at the keynote and earlier at James Clark's talk, we've done a lot of work to actually permit the system to scale content differently on different monitors. This is really big for Windows. This is something we've never done before. There was nothing like this that you could get in Windows 8 or Windows 7 or earlier versions of Windows. And so right now, I have a 200% scaling machine, my CuraBook. It's connected, it's in extend mode, since I'm giving you PowerPoint in presenter mode. And the display that it's presenting to is just a 1366 by 768 display. The system knows that this is a 200% and this is a 100% machine. Later on, as I'll be dragging apps back and forth, and you can see the difference in behavior. So it recognized both of these right out of the box. I didn't have to do anything, and it will start to do scaling for me back and forth as needed. Now, in the past, we had a single scaling factor for the whole system. We called that the system DPI. The system DPI is still there. What's new in 8.1 is that we also have per monitor DPIs. And the same technology we used to use in the past to scale content from one up to the system DPI on a high DPI display can be used in Windows 8.1 to scale content independently for different monitors. Finally, we've done a lot of work in 8.1 to support new APIs. I just said, if you've got it, what we can do is recognize these different devices and we can scale content for you, but that's bitmap scaling based on the output of your app. If you have an application that needs to be pixel perfect, that can't tolerate being scaled, for example, a high-end graphics art program, you need to be able to find out what the per monitor DPI is yourself and scale your own content to it using your own algorithms and methods. So we've provided the basic API support for that, and I'll spend a lot of time in this talk talking about that API platform. Finally, we've implemented a new little control panel for managing your per monitor scaling. I hadn't planned on talking about that a lot because it's not really a developer feature, but I realize there's a couple aspects of it that will be important, so I'll spend just a minute on that later on. Okay, so that's the work we've done. What kind of work is there for you to do? And I think the key message I want to make sure you're aware of as developers is that when we talk about high DPI, we're not just talking about lots of pixels. Here's a workflow that I might do at home, because I like to do ebooks on the side. And if I had myself a 2160 by 1440 desktop monitor, one of those 27 or 30-inch machines, I could put up all kinds of windows. I could be working on my translation, my markup. I could be working on the software I use that actually creates the EPUB books. I could be working on the artwork. I could be building things. I could be previewing content. All of that on screen at the same time. This would really be great. So that would be a 2160 by 1440 experience. But that's not what you want on a 13-inch laptop. It's really barely visible even at this size. So the point I want to impress on you is that high DPI is about more pixels, but it's really not about using those pixels for more content. It should be about using those pixels to provide better, clearer, crisper content. I'll give you a good example of that. So I'm going to compare some content at two different scale factors. One of them is rendered at 96 DPI, and the other one is rendered at 192 DPI, or we would say 100% and 200% scaling. And by the way, sometimes we'll go back and forth talking about DPI and scaling factors. We've done that in some of the other talks as well. Just think of it as 96 DPI, dots per inch on the screen, as something we regard as 100% scaled. And we support basically 100, 125, 150, and 200. Anything in between is going to get rounded to one of those in some way. So first example is, let's just put some text up on the screen. I don't remember exactly which font I used, but that was basically something I just did with Word. I wrote the word sample, I screen captured it, and I blew it up so you can see the individual pixels. On the left, at 100%, it's actually pretty hard to read once you start seeing all those little grayscale artifacts and so on in there. Shrunk down at the size of your screen, of course, you immediately read that word. But how much crisper and clearer is the same thing rendered with twice the number of pixels? Actually, 4 times the number of pixels, twice as many in the x direction and twice as many in the y. There's still grayscaling going on. You can see it along the edges of the glyphs. But the overall contrast is much higher, because most of the pixels are either pretty dark black or pretty white, and there's a continuous flow of the black ones, so your eye quickly recognizes that text. This is the kind of opportunity you have with high DPI displays. You can be giving people the experience on the right all the time if you scale your content for you. If you leave it to us, we will scale it so it's the right size. But if you give us that bitmap on the left, my left, your right, all we can do is make that twice as big. We can't make it sharper and crisper because we don't know the content that those pixels came from. In your application, you do. And so this is the opportunity you have. Here's another example using just some icon kind of glyph-like content. That's just the make a copy thing. You've seen it all in a million programs and applications. And at 96 DPI, there's a limited amount of space to represent that notion of making a copy. And on most of your machines, if you were to bring up Word or any other application that had this and looked at that, you'd be able to see the jaggies along that diagonal line. If you go to 192 dots per inch and 200% scaling, you get much finer details. And with those pixels being smaller, you actually won't see those jaggies unless you get very close to the screen. So, again, this is not what you want. There may be a few developers out there with young and nearsighted eyes who will eat this up. I certainly would have when I was younger, at least for a little while. But most of your customers are not like that. Most of your customers will appreciate and value this kind of an experience if you give it to them. Okay, so the issue then is not using this content simply as using the extra pixels simply for more content. It's how do we scale the content we've got so that we're making the most use of the pixels we've got. And this scaling is a partnership. I've already indicated that Windows knows how to scale content for you using bitmap scaling, but there can be a negotiation between your application and Windows where you basically say, I can scale this in this circumstance, so let me do it because I can do it better. And this is the negotiation and the partnership we have. So if you think of it from an application perspective, there are like multiple levels of investment. As a developer, you could start off on the ground floor. You could just say, oh, I've got this old application. I never thought about DPI before. It works okay on a low-density machine, and I tried it out on my Surface Pro, and Windows did a pretty good job of scaling it up. So what's happening there is your application is basically, we're treating it as DPI unaware. You haven't told us that it knows anything about DPI. So we take and we put it in a sandbox, a presentation sandbox. We basically say, you didn't tell us what your app could do, so we're going to assume it's only good for rendering at 96 DPI or 100%. If you make any calls to the system whose results depend upon what the actual DPI is, we'll tell you results based on 96. That way you'll get at least a consistent view of the world you're in. You'll do your rendering. Everything will look pretty good. You'll hand the results off to us, and when we compose the desktop, we'll scale it up to the right size. We'll also scale down the input because your coordinate system is not the one that's actually being displayed on the screen in terms of actual pixels. So the content in white is what we always have done in Windows 8, Windows 7, even Windows Vista. The content in black over there is what's new in 8.1. In Windows 8, there was only one system DPI. In Windows 8.1, we have a per monitor DPI for each different monitor. So we'll scale the output appropriate to that monitor. And The downside of this, as I've said, is we're going to scale your bitmap for you. The results can be blurry or a little bit jaggy because we just don't have as much information as we would if the content had been rendered natively at a higher density. What's new in 8.1 is that's only a problem for high DPI displays. If you've got a low DPI display, because we'll use the per monitor DPI, your 96 DPI content is probably just right. And we'll actually see that in one of the examples coming up. All right, for applications that wanted to make a greater level of investment, in the past we just called it being DPI aware. Now we're being very clear it's system DPI aware. And examples of this include Microsoft Office, Internet Explorer has always been DPI aware. The File Explorer in Windows and most of the internal UX has been DPI aware since Windows Vista. Firefox just announced that they're going to make the next version of the, and you can, in fact, you can download the beta now of their browser, and it will be system DPI aware. So when you declare to us that you are system DPI aware, and we'll get to the details for how to do that, then we still put you in a sandbox, in effect, but it's one based upon the system DPI. And in the past, that was all there was, so that was all there was to it. What's a little bit new in 8.1 is that your system DPI application can come up, say, on this thing and see, oh, I'm 200%, let me scale myself for that. You could end up getting moved to another monitor where it's only 100%. At that point, we'll step in and we'll say, we know how to scale you. We're still going to tell you you're at 200% because we don't know what particular choices and logic decisions you've already made based on that. So we'll just take your output and scale it down, and we'll scale up your input accordingly. So what's new is the DWM will start scaling you if the system DPI is not equal to the per monitor DPI. And the result is that your application now can get a little bit blurry on a secondary DPI, even though you wrote it to be DPI aware and crisp on the primary. We think that's a good trade-off in terms of the alternative being that your application is going to be too big on that secondary. Just a couple more words about some details behind the scene here. When we scale things up, if we scale things from 100 to 200% in Windows 8.1, we'll actually use pixel replication. We can just double your pixels in both directions. So the result is actually pretty darn crisp. And the experience is pretty good. And then on the second tier, where we say we'll scale things down, it's worth noting that we don't just use a linear scaling algorithm. We actually use a super sampling algorithm leveraged from the work in the DWM that already provides thumbnails. And those results are actually pretty darn good. They're much better than scaling up. Rather than saying blurry, I would be tempted to say there may be a slight loss in contrast in some very faded UI. And I'll show you an example of that. So that's the second level of investment. The third one that we want to talk more about today is becoming per monitor DPI aware. And so this would be for an application that really wants to control itself completely. It doesn't want us scaling the content. It needs to have crisp content everywhere. We've provided the API support for that so that you can declare yourself to be that kind of an application, and we'll leave you alone from there. All right, let me give you a quick demo of some of this. I'm going to back out of PowerPoint, and I'm going to bring up a couple apps. First one is just the old disk management utility. This is actually a DPI unaware application. You've all seen these demos where we drag stuff across now and they get smaller because we'll shrink them, and you see that does work. But I wanted to pause just right here to stop it for a minute. It's a little bit hard to tell, but as this is being pixel doubled for the 200% scaling here, there is a certain amount of jaggedness to some of the text. You may be able to see that, especially on a 100% desktop monitor. But as I said earlier, with unaware content, once we snap it down in size, we start actually using the content that was rendered directly by the application at 100%. So that's as good as you would get on your primary today. If you were to do this experiment on Windows 8, it would be not only the wrong size, but it would be noticeably fuzzy to the point where you might not even be able to work with the application for very long. So I'm going to take that one back. That was a DPI unaware app. MS Paint, also in the box, is a DPI aware app. You can see here that like the text where it says edit colors is not at all as blocky. It's actually being rendered at 200%, so it's a better experience. And again, this is the opportunity you have to make your apps DPI aware. And when we scale that down, here's where you can begin to see maybe a little bit of loss of contrast. These faint dividing lines in the ribbon are not quite as crisp and clear as they were before, but the text is extremely readable, and all the content is very good. So we're pretty happy with that. Finally, I'm going to throw up a a little test app that is actually per monitor aware. And it will also shrink down. And I think you've seen, if you saw James talk this morning, you saw something like this where we're picking an asset, which, let me just stop this right here. That is, that's an icon, and we have a family of icons. We'll look at the source code for this in a minute. And we're actually picking the one that's appropriate for 200%. But as it scales across, it finds out that it's on a new monitor with a different scale factor, and it goes off and it picks a 100% asset instead. It also scales down the text, and it changes the contents of some of the strings that it's rendering, just so you can see it's now, yes, I am now 100% aware. I'm now rendering at this size, and I'm using a smaller font. So we have the three classes of apps. I've shown you examples of all three of them. And just the final point to make on this one, the text is crisp at both sizes. The experience is really great. So if that's the kind of application you need to, and experience you need to present, this is something you should really be looking into. So let's come back to our slides. All right, so what's required to make either a system DPI aware app or a per monitor aware app? There's actually quite a bit of overlap, and this is important to understand. First of all, you have to think about your content. Never before in writing a Windows app did you really have to think about how big things should be, because most of the time it was about the same. Now you have to actually think about it. How am I going to scale this? In the example I just showed you, there were bitmaps. You had to choose between different bitmaps. You had to change the scale of the text and so forth. So think about all of that. What is your strategy going to be for scaling it? And try to encapsulate as much of that as possible so that it becomes something you can modify without having to change your entire application. Think about it as a good object-oriented design and encapsulation kind of thing. And the examples we'll show have scaling helper classes that exemplify that kind of thinking. Once you've figured that out, you have to tell us what kind of an application you've got so that we can avoid scaling you if you're scaling yourself. You have to figure out what the right scale factor is, whether it's going to be the system DPI for a system DPI aware app or the per monitor API, DPI if you're going to be a per monitor aware app. And finally, if you're going to be per monitor, you also have to be capable of listening for changes so that if you're moved between one app and another, we'll scale you properly. Now, I said listen for changes in the scale factor, and I said drag between one monitor and another. I should take note that it's possible for the scale factor to change for reasons other than being moved between monitors. And this is probably a good time to break out of here for just a second and take a look at the new CPL. So this is the new CPL for scaling. It used to look like this, pretty much. You probably have seen this before. And that's still there, but it's not the default behavior anymore. The default behavior looks more like this. You notice a couple things. We don't talk about the numbers anymore. And the reason is we're trying to make it as simple for you that there's one slider that you can adjust that pertains to all your monitors. Now, your monitors are not all the scale factor. I already told you this one is at 200 and that's at 100. So what number would I put there? I suppose you could put 200 below and 100 above, but then what happens when you have 3 monitors and 4 and so forth? So to keep it simple, we're just providing this qualitative scale, smaller to larger. If for some reason you prefer the Windows 8 experience, you can go back to it. And now you're using one scaling factor that applies to all your displays. Now this is a little bit confusing, potentially. When we say one scaling factor, we mean 100% or 125 or 150. The result of doing that is that the actual size of your app may change. And that's the thing we've been trying to get away from. So if we leave that in the past and leave it behind, by default, you can make things bigger or larger, bigger or smaller, but that change will apply to all your monitors, and we will try to optimize your experience so that an application has the same size when it's moved from one monitor to another. So this is a second way that DPI can change. And unlike the old days where you had to actually apply and then log out and log back on, in this new design, you can actually change this on the fly. And the reason this works is that the DWM can apply this delta in scaling. So let me get that down out of the way. Let me bring that app back across. Okay. And bring back up the control panel. Let's take this all the way down and apply it. And that, oh, this, actually didn't see the change. Oh, I know why. Yes. It relies on some API support that actually is not in the preview build. This works on machines at work, but not here. So sorry for overpromising on that. I can see it on this screen just fine. But anyway, that is an accepted way of changing the DPI. And the nice thing is that it does happen on the fly without logging out. The one caveat there is that because DWM is doing the scaling, there may be some blurriness or loss of contrast. And so if you do make a change with the CPL and you really like it, maybe you like everything's a bit smaller because you've got those younger nearsighted eyes, or you want things larger, after you've chosen the size you like, at some point at your leisure, log out and log back on, and we will set that as the new system DPI, and that'll be kind of the default starting point, and you'll get a crisper experience. So I wanted to talk now about how do we actually write a per monitor Win32 app. And the best way to do that is just plunge in with, it's the app we just saw, in fact. So this is called DPI tutorial. The version I've got here is slightly stripped down. The version that's going to be posted on MSDN has a little bit more complexity to it, but I wanted to kind of strip it down just so we could focus on a few simple things. So first of all, I said, think about how you're going to scale the content. And I already kind of talked through that. I said, you know, you've got text, you've got bitmaps, you've got some other content. So let's write a scaling helper class that tries to wrap up as much of the scaling material as we can. And so here is the class. It combines a few things. It's got some member functions and some member data. The data is basically, what is your scale factor? And also, what is the level of awareness of your process? We actually wrote this so you can change that on the fly and, or recompile it different ways and see the different kinds of experiences you get. So that's the kind of the private data that the helper class is encapsulating. We provide functions like scale here that actually do the work. They have access to the internal scale factor, and they return a value that's scaled by that version over 100. So, for example, the scale factor is 200. You're going to end up doubling things with this function. We also have to have a way of setting the scale factor that the system's going to be using within the app. And this was the simplest form of it, where you provide an actual DPI, which you can get from the system, and you set it to this, you make a call on this method. That sets the value internally, and you can proceed from there. There's a more complicated version that's worth taking a look at some point, where we set the scale factor from a rectangle. That's more complicated because a rectangle can actually span 2 monitors. And so the interesting question is, which scale factor should you use? We basically have a heuristic of, we try to go with the one that most of the area is upon. But there are a few corner cases where that actually gets a bit ambiguous. And you just think about this for a minute. If your window is straddling the border between 2 of them, it may be that more than half of it is over here. But if you applied that scaling factor, or maybe more than half of it is over here, if you applied that scaling factor, all of a sudden more than half of it is on the first monitor. So you have to kind of work through that a little bit iteratively. And I actually have code here that does that. It's worth taking a quick look at. But for purposes here, we'll just say that works. You have to have a constructor that actually builds a working instance of this class. And here all it does on initialization is get the current process DPI awareness. This is part of our new API surface. And so it sets that and squirrels it away. It sets a default scale factor of 100 because we're going to use that other function later to actually set the real value. You create an instance of that. Here it is, G under DPI. That's just a global for this particular sample. And we'll just use that and the scale method and things off of it to make things happen. So for example, to render the content, here's an example. We want to put some padding around the inside of the window so that we lay out content and we're not overriding the edge of the window. Well, that value has to be scaled. And so there's the code that makes that happen. We have to scale the fonts, and the code that makes that happen right here. See, again, just applying the scale factor and applying that to a font height, and then calling a little utility up here to actually create the font. Now notice, this is part of the thinking you have to do when you're talking about planning your content and how you scale it. Creating a font is a relatively heavyweight operation. You wouldn't want to do that with every text string. So it's separated out into some helper functions of its own where you create the font, and then if you need to, you throw it away when you're updating it. So So this basically now has everything it needs to do, except you have to tell us that you're going to be DPI, per monitor DPI aware. And the way you do that is in the application manifest. So the easiest way to do that is just in VS anyway. You can just come to the manifest tool, and we're under input and output. And here's the DPI awareness, and you can see what the options are. You can be none, which means DPI unaware. You can be high DPI aware, which is system DPI aware. Those are the two values we always used to support, and now we have per monitor high DPI aware, which is the new option, meaning you're actually aware of each one. If you don't like working with the manifest tool, you can use additional manifest files, and you can create a file and enter the XML yourself. Or if you've got some other kind of a software development environment, you have other ways of creating that XML file. But it's kind of nice having the support in the SDE for that. So we now have everything in place, and you can just build and run this app. And as we saw it before, it's rescaling all the text. Oh, the other thing we didn't touch upon is the bitmap. There is a case statement in there that picks that out. It's worthwhile just getting that. And there it is. We have a switch. We call the helper function to get the scale, and we just use the result as to power the various cases, and we pick the various bitmaps accordingly. So you plan the thing out ahead of time. You write your various fixed assets like these bitmaps. You decide on your text. You figure out how you scale that. You wrap the whole thing together. You tell us that you're going to scale yourself, and you've got a little Win32 application, kind of a hello world DPI, per monitor DPI aware. And I should say, how do you know that the DPI has changed? I don't want to skip past that part. So, if this is a Win32 app, you've got your own little WinProc. You just have to listen for this new message, WM DPI changed. The content of that message is really critical. The W param actually gives you the new DPI, and the L param contains a rect, which we think is where your window should go. We do this so you can, if you just use this and use this W param and this L param, just call set window pause with it. So you set your new scale factor, and then you move the window. Your behavior will be identical to the DPI, system DPI aware and unaware apps on the system, and in that you'll get that same consistent resize behavior everywhere. You can, of course, kind of roll your own here. You can get the scale factor, and you can decide, well, I don't want to be like straddling. I want to snap somewhere, and figure out your own logic and do that. But if you're going to do that, be mindful of the fact that if you're going to be straddling the window boundaries, you have to be careful that you have a nice deterministic positioning, and that you don't alternate back and forth between two positions depending on slight variations in the position. And this is that whole scaling versus size thing I alluded to earlier. And then, so in the rest of the code, we recreate the fonts with the new scale factor, and we draw the content. So this is really pretty simple. Not at all that hard to do once you've thought about how your application should be handling things. All right. So I'm going to skip back to the presentation. So just to recap, plan how you're going to scale your content. Creating a scaling helper class to manage the scaling is really helpful. That can track the scale factor for you so that it's private. You don't have to have references to it scattered everywhere. Instead, you can just have nice method calls. You can use those methods during your rendering code to scale things on the fly, or to set up things like fonts. So think about your initialization, your layout, and your rendering. Now let us know you're going to be doing the work, and I'll provide a little more detail here. If you're doing a manifest, this is the kind of content you'd be providing. In the past, where we said per monitor, here you could have left it blank. That would have been DPI unaware. You could have omitted the whole thing, and we'll treat you as unaware. You could have specified true, which is system DPI aware in Windows 8.1 thinking. And then per monitor is the new thing in 8.1 that tells the system that you're per monitor aware. One other new thing, I don't know that anybody's going to need this. We've had a couple ISVs that really wanted this. They want to ship a single binary that works on both 8 and 8.1. Of course, in 8, you don't have per monitor awareness, but they wanted it to be system DPI aware there for best results. 8.1, they wanted it to be per monitor aware. So we came up with a true/PM as kind of a hybrid, and that solves that down level problem for them. Just a word, you can also do this procedurally. There's an API call you can make to set awareness. We don't recommend doing it unless you absolutely have to. I'll show one place where you might have to do it in the course of a later example. The reason basically is that if you do it procedurally, then there's kind of a race condition within the context of your application. You get initialized, and at some point you call us and you tell us, I'm per monitor aware, please. Well, if in the interim you had made any system calls that depended upon this level of awareness, you could have a mix of, say, unaware data and then later aware data. And all kinds of interesting things are possible there. You could end up with layout, inside-out layouts and things like that. So if you are going to do it procedurally, it has to be done very early on. And I'll give you an example, one place where that makes some sense. All right, figuring out the right scale factor, that's pretty straightforward. But I'll just give you a little bit more detail here. We have the new API, get DPI for monitor. You specify the H monitor. You get back a DPI X and Y. They're almost always the same, but some monitors have slight differences, so we decided to just support that, partly because the D2D rendering factory supports having a different scale factor in X and Y, so we have a complete story there if we need that. The interesting second argument is the monitor DPI type. There are like three different kinds of information you can ask for. The most important one by far is that first one, 0. That's why we make that the default value. The MDT effective DPI basically says, just tell me 100%, 125, 150, 200, that's all I care about, and I'll scale my content based on that. That's probably good for almost anything. But you may be, for example, you may be, say, Adobe Photoshop or some other graphics art program where there are times when you have to render content on the screen that is exactly the right size as the print copy or production copy will be. So we also give you this MDT raw DPI, and you specify that value, and we'll come back and we'll actually tell you 228 DPI or 208 for your Surface Pro. So you can get that kind of data if you need it. And then finally, there's a kind of a hybrid version, which so far only Internet Explorer and other browsers have asked for. The idea here is you want to also have a very exact value, but you need more granularity than our 100, 125, 150, 200. And for example, if you have to render HTML text, and it becomes a competitive advantage to render 7-point type at exactly a certain angular size because that's what the spec calls for, this is the value you could use. This would actually come back and give you a number like 213 or something that would then let you be able to size the content appropriately. But it's a very rare kind of thing. I don't expect most applications would need to take advantage of that. Finally, you can listen for changes in the scale factor. And again, WMDPI changed. You get the W param and the L param with all the information you need. And to update your window size, you can just call set window pause. I call this out because if any of you have ever tried this in the past, in a move size loop context, we actually ignored set window pause, and we now honor that call, so you can make that. I got 21 minutes left. Okay. Pardon?
Could you do that in the Windows form?
WinForms. So WinForms are actually not really very DPI aware.
It is, but to get, handle the WMD prop and
So I will show an example with WPF where we do something, and maybe you can apply that back to WinForms. I'm going to have to run, though, because I'm already running over. So I'm going to ask people to give me questions afterwards. I'll get off stage and talk. All right, very quickly, I wanted to talk about writing a D2D app that's per monitor aware. There's a couple reasons why this is worth spending an extra bit of time talking about. First of all, we've been talking about D2D as kind of our new strategic direction for desktop graphics for some time. You've got the graphics acceleration. But from a DPI perspective, what's really nice is that D2D is not tied to the pixels of the screen in the same way that GDI and Win32 are. The D2D actually specifies everything in device-independent coordinates, and you supply a scale factor, a DPI-X and a DPI-Y, to the D2D factory as part of your initialization, and then it does all the scaling for you. So this is a much simpler story in the sense that you don't have to worry about resizing this rectangle and resizing this text, all those things get resized for you as long as you do your layout and specify your content in these device-independent terms. So that's a really great thing with D2D. You still have to select some assets, like the bitmaps, based on the scale factor, and in fact, when you select them, then you actually have to tell D2D, oh, don't scale this thing, and I'll show you how to do that. But there is another powerful new tool that we're shipping in 8.1 that actually solves the asset problem, makes it much easier to deal with. So let's skip out of this for a minute, and I'll bring up the next code snippet. Okay, this one is not on the web for you right now. We'll have a version of this somewhat later. But let me just show you what this one does when we build it. Okay, this actually is very similar to the one James was showing off earlier. And so if you saw his talk, you've seen this. It's D2D. It shrinks down just like any good app should, but it's doing it on its own. And I think a few things I wanted to call out here. Again, you get the text that's scaling, but as we'll look at in the sample code, you don't have to do anything to specifically scale this text. D2D does it for you. There's also, actually, just for fun, a little rich edit control, which pretty much works. Wired up to some buttons. Does all the rich edit control kind of things, indents and so on. There's a fixed size asset over here, which right now you see it's picking the 100% version, much like the previous sample did, and then now we're using the 200% version. So let's just look at a bit of the code on this one. Let's bring up those bookmarks. Those are so helpful. All right, how do you set the awareness? Well, it's the same thing. It's the application manifest. It's exactly the same kind of logic, so I'm not going to walk through that again. How do you know that the DPI has changed? I'm going to walk down through several layers because this application has several layers of abstraction. But on the very highest level, the WM DPI change gets mapped to this handler. And if you go to that thing, it ends up calling down into on DPI change. Some of these levels are for the sake of the application. Some of them are for the sake of the helper scaling library. On DPI change ends up calling down. So it makes a call to set new DPI, and I'll look at that in a minute. It also scales the rich edit window, because that's a Win32 thing. D2D doesn't know how to rescale that for you, so you have to add support for things like that. It sets the new window pause right out of the message. And now then just look at this set new DPI. Basically what that does is, well, if the DPI has changed, let's set the new value on the device resources, and this is basically right next to the D2D context itself. So this is where the DPI actually plugs into the D2D factory and powers all the scaling. So you just have to connect the dots and make sure that gets plumbed down to that level, and again, all the scaling happens for you. Well, almost. As I warned you a little bit earlier, we still have to do a case statement to pick the right asset. And then you have to worry about the fact that when you scale that asset, you have to actually disable the D2D factory DPI scaling. And you do that by specifying that the unit mode is going to be in terms of pixels. And you draw the bitmap, and then when you're done, you set it back to dips, that being the mode that gets you the scaling for free. So it's still a little bit awkward, but good news. You really don't need those fixed assets anymore, because we have this thing called a color font. And the color font basically is a way of presenting things that used to be done as icons as completely scalable, but color entities. Color font looks a lot like a text font, but the material inside it can contain different layers with different colors. So you can actually draw multicolor glyphs, and they will scale just like text will. For details on that, there's a whole talk by Dan McLaughlin on D2D and changes for 8.1. I'll send you there, but for here, I'll just point to a couple quick things. To add a button, you just basically, there's actually, this sample code actually has a little button control. And so you can basically new up a little button here. You can assign it a click handler, which calls a helper function in the rich edit window code. And that's basically how all those little buttons that I showed you were working. Let me bring that back. So all these things over here that look like buttons are actually, those are all color font glyphs. And it's basically text in the color font rendered to an area on the screen. It's got a little bit of support for hover, and it's wired up to do things on the rich edit control. So in essence, I think the fact that you can do this with these scalable color fonts means you can stop worrying about all this asset management stuff, unless you've got very large assets for which it might make sense to do some work on your own. But this really solves the asset management problem in a really nice way. So back to my slides. Let's minimize this guy, that one. So just to quick recap. Same manifest technique for declaring yourself to be per monitor aware. Scaling is a little bit easier to centralize because D2 can really do about everything for you unless you have some of these old style image assets. But if you do, you consider moving to color font technology and getting away from having fixed size assets. Make everything scalable right from the gut. And the sample shows how you can incorporate that in some simple button controls, and you can apply. And notice you can also incorporate Win32 controls like the rich edit window, but although you have to do some manual scaling work on them. So some really rich possibilities here with D2D. Finally, I wanted to just very quickly touch on a WPF app and how you can actually get that to scale itself. James actually showed us a little bit of this morning, but I'll dig down into it just a little bit. So let's cancel out here and bring that last one up. All right, so James actually just found this nice little sample app from Telerik, I believe, online. They encourage people to download and play with it, and he modified it in order to create a little, he found a soccer thing because as he says, he's a Brit and he likes soccer. So he had this little thing, and you may have seen it this morning when he was showing it off. It's a per monitor aware WPF app. The whole thing's written in WPF, and basically all this content is being redrawn by WPF by applying a new root transform when it moves between monitors. So you could do things like that with WinForms too. We haven't tried to plumb through all the details of how that would work. But let's just look at how this works here. It's a little bit tricky because WPF actually, by default, is is actually DPI aware in the system sense. It was designed to be that way. And rather than changing that, we just came up with a way of, first of all, you can disable the existing DPI awareness with this assembly instruction as part of your manifest information. And then you can add per monitor awareness back to it by actually calling the API that I alluded to earlier, where you can actually programmatically set the DPI awareness. And this code does that. Now, I warn you, you have to do this very early on. So the way to do it really early on is to make this happen during initialization. And the way you can do that is by having this as part of the constructor. Here's the this helper library has the set per monitor DPI aware function, which is actually set as part of the construction, part of the app launch, as is adding the message handling. So let me run through these other pieces. Here's this native helpers thing, and we see we have a per monitor DPI window. Its constructor basically calls something that adds a routed event handler and hooks it into the message processing for the WPF app. The routed event handler is defined here, if I remember right. That was the message handling. Okay, yes. So it on load, basically, this thing adds on load, and then on load adds handle messages, and that basically adds a little bit of simple Win32 code to the message processing for your WPF app. In particular, you're listening for WMDPI changed, and you can drive that on down into the framework in the app. And the best way of showing that is on DPI changed. There's two parts of it. The part that you need to do for any WPF app is to update the layout transform. I'll get to that in a minute. And then you can also, if you're going to do any app-specific things, and if any of you saw James talk this morning, he actually went into that routine and commented out some code so as to actually change the presentation of different DPI. The thing I wanted to focus on here is that the update layout transform actually changes the scale transform applied to the child of the root visual. It gets the visual child. It compares the current DPI with what it was at the time the application was launched, gets the ratio, creates a little 2x2 transform based on that, and sets that transform property on the child. And that does all the scaling for you. So there are things like that you can probably do with a number of different old app scenario, frameworks and the like. We haven't tried to exhaustively figure them all out. So, 9:35 left. Let me come back to my presentation. I minimize this guy. Bring this back up. So to recap, if you've WPF, the scaling is pretty easy because WPF literally scales everything for you. You can write a scaling helper function, as we did before, a little library and a class that manages the display and the DPI changes. For WPF, the way you would apply that is to set a root transform. You have to set the per monitor awareness procedurally through an API call. And that's that. So, very quickly, let's talk about wrapping up here. I've given you basically three options of investment. One is DPI unaware, one is system DPI aware, and the third one is per monitor DPI aware. I think the point I really want to bring home is that becoming at least system DPI aware should be your high order bit as a developer. That's a perceptible differentiator on your high DPI displays. So you can let Windows scale your app, but you'll look much better on these high DPI devices if you are system DPI aware and do the work yourself. There's a couple reasons why. As I indicated earlier, when we scale content up, there's kind of a limit to the quality. We don't have all the data that you have. We can only make things bigger. We can't actually make it crisper and clearer. Whereas when we're scaling things down, we can subset the information in an effective way. So the quality of downscaling is much higher than the quality of upscaling. And that means if you had to choose between being an unaware app that gets scaled up on the primary but looks good on the secondary, or a system-wide aware app that looks great on the primary, pretty good on the secondary because the downscaling is better, you should really be aiming for that second scenario. In the first place, the primary experience is the primary experience. Most of the time, most people will be working on their primaries, not on the secondaries. We have to make the secondaries work. You need to make sure that they work for you. But your primary investment should be on making sure the experience is great on that high DPI display. So go with DPI awareness because that gives you the best experience on the most important scenario. What that means is then, well, when should you become per monitor aware? Well, it is important in a couple cases. One is if your application gets widely used in multi-mon projection scenarios, then you want to think about what do I need to do to tune up that experience on my secondary. Or if you've got like a graphics art app where you have to be able to provide a pixel-perfect rendering on all your displays. I mean, you would, if some of you saw James' presentation earlier, you probably saw Adobe got up and showed an example of Photoshop and Lightroom running where the UI had been doubled. You could probably get an effective-looking UI by just doubling the UI, but if that meant scaling up the graphics content so that what you were looking at on the screen was not what was really there in the backing store, that would be death for a graphics artist. So if your app falls in that category, think really hard about this. Now, the good news is, if you become system DPI aware, what do you have to think about? You have to think about how you scale your content. You have to tell us what you are. You have to get the DPI and scale stuff. That's almost all you need to do to become per monitor DPI aware. To become per monitor DPI aware, after you've made that first investment, you then just have to listen for changes in the per monitor DPI and respond to that. So it's just one thing after the first three. So focus on that first thing. It gives you the biggest bang for the buck, and it gets you very close to where you'll want to be in the future. All right, a wrap up. Now, Shakespeare says, there is a tide which taketh the flood, etc., leads on to fortune. It's a great line. could apply to just about any technology shift or cusp or ecosystem shift. And we claim that high DPI on the PC is exactly that kind of thing. If you take advantage of this, you can make stunning apps. They'll look gorgeous. Let me just say, from my personal experience, I've been using this Kira book for about a month and a half now. I don't know how I could ever go back. It's really painful for me to use a traditional DPI machine because suddenly I become aware of the pixels that I never used to notice before. And this is a common thing we've seen in this business where, some of you may remember, I certainly do, when color came to laptops. And people would tell me, who's going to spend $1,000 more for color on a laptop display? Well, we wouldn't even think that question today. And I believe that high DPI has that same kind of promise, that once you start getting used to it and you see that extra clarity that you get with DPI-aware apps, you're not going to want to go back. And you're not going to want to use apps that are not also DPI-aware. So by taking charge of the way your app is experienced across a wide range of form factors and densities, you're actually giving yourself a chance to shine vis-a-vis the competitors that don't make that investment. And if you and your competitor shipping the same kind of product in the same kind of field and yours looks better on high-end devices, that's a big win for you. Alternatively, if you let them get in first, that could be a problem. So I think this is a really important thing for all of you to be thinking about in your application space, particularly if you have a chance to be developing new applications. It gives you a chance to get on the ground floor and think of DPI as a design principle for desktop applications. Don't think of it as kind of an afterthought, but just think of this as something you need to build in from the outset. If you've got a lot of old, really crufty code, that's a harder story. So, you'd probably taken a look at that rendering code, and you know that in order to scale this, you'd have to go into 17 different modules and be scaling all kinds of different content. But for new application development, this should just be a slam dunk. Go DPI aware, and then if you have that kind of application where you need to be, become per monitor DPI aware as well. So that pretty much wraps me up. I wanted to spend just a minute to talk about some of the other resources here. James Clark's talk this morning, you can view that later. That shows DPI as well as some other desktop application technologies in Windows 8.1. I alluded briefly to the Store Apps story. In a word, HTML and XAML, your primary technologies for Store Apps, actually incorporate great per monitor high DPI support in at the ground. The framework themselves handles the DPI change and does it for you. The only thing you have to be aware of there is basically picking up different assets appropriately. So there's a great story there, although it's not a desktop story. I want to refer you to that talk. That's tomorrow. Dan McLaughlin's got this great talk on all the high-performance 2D graphics. That includes things like D2D and the color fonts. Good place to go for more information on that. There is a white paper. We've had a white paper, actually, since Windows 7 that was high DPI support. We're updating it for 8.1. That update includes this new DPI tutorial that shows how you can take the same code and add per monitor awareness to it and how to bring your application forward. So that's an important thing to go take a look at. I think that's going to be live fairly soon. I've shown several samples. One of them, in fact, was that DPI tutorial. The others will be up on MSDN later, but I don't have an exact date for all of them. We're still iterating on some of the details. So there's a lot of stuff there, a lot of content, and then a lot of these machines out there that you can start designing for. One last thing, I realized as we got prepared to give this talk that it's a little bit hard to make the case for how beautiful high DPI is on this device. And it's nothing to do with the equipment. It's just that these projectors are actually 1280 by 720. And the content in the extend mode that most of us are showing is 1366 by 768. So no matter what we do, the content we've got up here, and I can see the difference. This content is getting scaled and refiltered over there. So you're already seeing kind of a couple levels of scaling beyond what Windows would try to do with what the DWM would do in scaling content. But the good news is you've all got 150% scaling Surface Pros coming to you. You'll be able to actually look at some of this stuff running on those devices. And I really urge you to take a look and see just how beautiful a lot of content can be when you've got that kind of pixel density to support it. the crispness and clarity of the text, and then see if you are not as unable as I am to consider going back to lower DPI devices in the future. It's just really quite compelling, very beautiful. So that kind of wraps up my talk. I'll stay around and answer specific questions for a few minutes and find me in the speaker room after that. I hope you've been excited by, yes, high DPI for the desktop. Thank you very much.